I restored my 10-year-old Samsung laptop, an Intel Core i7 laptop, into a desktop and made it 25% to 50% faster. That was done really cheaply as I had used wood instead of steel or aluminum. The wooden casing with mounts and screws cost me around 16 ringgit, which is about $4. Since I broke some parts, I had additional costs to replace them. The additional electronic components cost me about 113 ringgit, which is about $27. Let me show you how I did it. I had some problems with my old Samsung laptop due to aging. As the laptop was old, I had noticed that it had slowed down, so I took it in for servicing. The repair technicians cleaned up all the dust blocking the fans and changed the old dried up thermal paste with a fresh coat to improve the heat transfer from the CPU to the copper cooling tubing. That improved the speed of the laptop by 25%. I used Cinebench R20 to check out the performance improvements. The problem with this old broken laptop was that the plastic casing, due to its age, had become brittle and was breaking and falling off. Worse still, the speakers and the microphone had stopped working a few years ago, but I didn't want to repair them as I had switched over to USB devices. I had to take it to the repair shop to dismantle the keyboard and the screen as it was too tricky for me to do. I had upgraded the hard drives earlier. This was because they were based on a 10-year-old technology. I upgraded the laptop hard drive to SSD for C drive by changing this hard disk to an SSD. This really helped to speed up the boot up performance of my laptop. Then I changed the internal D drive to an external hard drive for my laptop. This ensured that all my work could be moved safely and without difficulty from one laptop or PC to another. Having changed the internal drives, I then looked at dismantling the laptop casing. It was not easy as I did not know how to remove the keyboard and the screen. Technicians at 2 different repair shops helped me with that. Now that I had the laptop motherboard separated from the casing, I ran some experiments on improved cooling of the CPU and GPU. I found that I could improve the performance of this CPU by another 35% if I had fast airflow on the solder side of the motherboard. All the while, I had balanced the motherboard on 2 pieces of wood to run my airflow cooling experiments. So it was after this that I thought about creating a more permanent casing with better airflow for cooling. As you can observe, I was using my TV screen as the laptop screen by connecting the laptop to the TV screen with an HDMI cable. That meant that I didn't have to use the laptop speakers. Now let me show you how I made the casing with the cooling fans. I laid out the laptop with the keyboard and screen on the plywood to take measurements as to how much of the plywood I have to cut to make the casing. Then I mounted 2 wooden beams that were just under 2 inches or about 4.5 centimeters high to provide plenty of airflow under the motherboard. This is at a different height to standard motherboard spacing. The standard spacing between the motherboard and the casing is about 1 centimeter or under half an inch, which means it is not possible to place cooling fans underneath the motherboard. This is because I wanted to have the heat generated from the CPU and the GPU to be conducted out through their leads or pins of the GPU and CPU packaging. I had shown in an earlier video that this was a more efficient method of cooling the CPU and GPUs. Then I mounted the motherboard onto the wooden beams with red rubber washers and wood screws. Red rubber washers similar to those black washers in your household taps prevent any shorting of the pins, leads and tracks on the underside or solder side of the motherboard. After that, I checked that the battery could be mounted without any problems. I will move the battery to the side later when the battery connectors arrive from China. Having confirmed the battery position had no issues, I brought in 2 fans to blow under the motherboard. Later, I plugged in the HDMI cable to my 41-inch TV as I was not using the laptop screen and attached a USB mouse and keyboard as I was not using the original laptop keyboard. Then I connected the mains cable to my laptop. After that, I switched on the laptop to verify everything was working well. All I needed was the motherboard from the old laptop to transform it into a fast desktop computer. I used Velcro to attach my external hard drive as D drive because I hadn't decided how big a drive, whether I would go for the 3.5-inch or 2.5-inch drives later on, and would there be place enough to attach it to the laptop. Then I joined the 2 fan wires so that they could be driven by a separate independent 12-volt supply. Let me explain the proposed theory behind cooling the underside of the motherboard. Most cooling fans try to cool the CPU package, but there is some heat gradient between the CPU die and the protective encapsulation. This means that not all the heat will be conducted away by the cooling fans mounted outside on the top of the CPU packaging. If we conducted heat through the leads of the CPU, it will cool the CPU die at a much better rate of cooling, as there would be no temperature gradient between the CPU die and the leads, as they are excellent heat conductors. That explains why blowing cooling air on the underside of the motherboard can be very effective. Initially, I had my cooling fans for my laptop held by cotton buds and cable ties because the hardware shop had closed, but this was very flimsy. When the hardware shop opened the next day, I changed them to a small L bracket, which was a much firmer build. The first time I ran Cinebench R20 without the cooling fans on, the score was 725. When I switched on the fans, the score dropped to 715. That would indicate there were other problems with my hardware. Without the cooling fans, the copper tubing temperature was around 58 degrees Celsius or 136 degrees Fahrenheit. When the fans were turned on and cooling the underside of the motherboard, the copper cooling tube temperatures dropped to below 48 degrees Celsius or 118 degrees Fahrenheit. This indicates that the solder side cooling of the motherboard is very effective. You can see the red laser spot, which is the place where the temperature is being measured. I ran the Cinebench R20 test again the next day. I found that the Cinebench score was 499 without the fans on. Room temperature was around 31 degrees Celsius or 88 degrees Fahrenheit. When I turned on the laptop cooling fans, the Cinebench R20 score was 672. That is, the cooling fans ensured the laptop ran 35% faster. I suspect that either the temperature sensors internally in the CPU are failing, which is unlikely for thermocouples, or the internal ADC to convert analog measurements to digital numbers is off. That would cause the CPU to think it is overheating when it is not, and to think it is cool when it is hot. If you take a piece of metal and heat it, it will stay around that temperature. The metal piece will not fluctuate its temperature wildly. And similarly for the silicon chip. Since I broke the original Wi-Fi aerial on my laptop, I had to buy a new Wi-Fi adapter with aerial and plug that into my USB 3 hub. So now I have internet access again through my internet router. I plan to mount the battery on the side when the 7-pin male plug and female socket arrive from China. Then only can I mount the reset switch on the side with one of those red rubber washers. That will complete my conversion of my old laptop to a faster desktop computer with a larger TV screen as the monitor. I must say that it was quite enjoyable converting my Samsung laptop to a desktop. The main worry I have is that the Intel Core i7 laptop CPUs may have some design flaws. This is because my Samsung has an i7, second generation i7 CPU, which is the i7 2630QM CPU. But when you look at the temperature fluctuation, it's very erratic. It runs from the range from 60 to 80 or 65 to 92 degrees Celsius. That's about 20 degrees Celsius or 36 degrees Fahrenheit within 1 or 2 seconds. That is an impossible fluctuation in temperature. You take a piece of metal and you warm it up, right? Its temperature is not going to fluctuate so wildly, right? So that is where I suspect that there is a design problem with the second generation i7 CPU, because the temperature monitoring is really bad. So if it says it is 62 degrees centigrade, it may be at 92, right? And your CPU will overheat. Or if it says that it's 92 degrees centigrade, so we have to shut down and slow the CPU and let it cool, your CPU, your laptop will start running slower. And it's nothing to do with the actual temperature on the CPU. It is actually the temperature measurement that has gone haywire. The other thing I noticed was, for the 9th generation CPU, I have an Acer i7 9750H CPU. The laptop CPUs are based on a low power consumption design, and what I suspect is, because of its low power consumption design, there are some flaws in the design and it doesn't shut off. Again, here you have the same problem. It doesn't shut off when the temperature gets too high. If it hits 92 or above, it will not shut off, it will still let the CPU run. Why do they allow it to run at such high temperatures? Unless the temperature measurement is wrong, right? It may be recording 60 or 70 degrees Celsius instead of 92 degrees Celsius. So it says, okay, it's okay to run some more. And what happened is, my room temperature in Malaysia is 32 degrees Celsius to 35 degrees Celsius, which is about 90 degrees Fahrenheit to over 100 degrees Fahrenheit. And because of that, we have a secondary problem. The Acer laptops cooling is a big problem. It doesn't switch on the cooling. After just a few months after I bought it, it stopped working. The fans stopped working. It cannot accelerate. The NitroSense program doesn't work. And the combination of the poor quality design of the CPU, low temperature CPU, low power consumption CPU, and that stupid Acer fan not blowing has caused the CPU to blow, right? It has failed completely, almost 50%, because this CPU, the 9750H, has 6 cores, but after 1.5 years of using it, it's only running on 3 cores. Can you imagine? It's crippled. It's not running, it is crippled. The useless design. I regret buying an Acer. I will never buy an Acer anymore. I'm fed up with Acers. Now, the other thing I have to tell you is, I do not know whether this works with the desktop CPUs. Okay, whether they have the same problem, because I don't have a desktop, so I cannot verify whether it has this problem. And one more thing is, wow, it's really great. So now what I'm going to do is, I am going to convert my Acer laptop to a desktop. I have to strip out everything, take out the motherboard, which I have just shown you how I did it on the Samsung, and hopefully someone in the repair shop can change my CPU to a new one, and I can now control the cooling and make sure it runs for a much longer time. And I will test it, and maybe I will do another video about upgrading my Acer laptop into a desktop. At this time around, I will varnish the wood so that it looks elegant. You love this video? If it gave you some very good ideas and you learned a lot, please subscribe, because there are some more such videos coming.